Hi there! Now the hull is ready to laminate, and I plan to do that with epoxy and glass fiber. In the front here of the hull I will use a little bit thicker and more glass fiber, as that is the area which will be most exposed to impacts. In the back end and further up on the sides I can use less glass fiber to keep the weight down. This is a very light glass fiber, 160 grams per square meter, and it conforms very well to bending surfaces as it's twill woven. To get good impact strength I will use this woven glass fiber. It has a weight of 300 grams per square meter, so it's almost double the previous one. It still conforms relatively well with bending surfaces, although not as good to surfaces bending in several directions. So I will use this in the front and up a little bit here, where I will need the biggest impact strength. I cut out the thicker glass fiber first, as this layer will be laid first. The edges of this biaxial fiber are thick. I still choose to overlap the pieces to get a tough hull in this area. When I add this thinner fiber on top, I smooth out the thicker edges. I trim the edges to fit the hull, but not so much more, to not get so much wrinkles. I lay out the fiber opposite the length direction. A short sheet conforms better, although I get more edges this way. Here in the back end I will only use a light glass fiber, to minimize problem with air bubbles. I heat the hull to an elevated temperature before I start, but lower the temperature as I start to work. I don't want to overheat as I put on full protective gear. Most important are double gloves. This will prevent epoxy allergy even if the glove breaks. I will make 150 gram batches of epoxy, 100 gram of base, and 55 gram of hardener are mixed with the tumble mixing. While I'm waiting for the mixture to transfer to a new container, I get a squeegee and an aluminium roller, and a heat gun for driving out stubborn air bubbles. Now I can continue with the mixing. It's beneficial with several different mixing modes. Thus I use push mixing in the square container. Now I remove the glass from the starting area. So I can wet the wood surface. It will be easier to wet out the cloth if I have epoxy on both sides. Also, it's easier to get the cloth to stick to a wet surface. This thicker and stiffer cloth still needs to be pressed down. Pressing and wetting makes it possible to bend around the bow. Laying down the thinner cloth will also help with conformance. This cloth drapes very nice around the bending surface. I just need to adjust it so it covers the whole surface. The thick cloth releases some epoxy into the thin cloth, but I still need to add some more epoxy. Adding the thinner cloth on top of the thicker makes the edge of the thick cloth almost invisible. I get a very smooth transition between the different thickness areas. I continue wetting out the cloth from the bow and outwards. It is important to keep the cloth smooth without wrinkles. If the air bubbles are not pressed out, they will remain after curing. This will make the laminate weak, prone to further delamination, unnecessary heavy, and with more moving resistance than necessary. I repeat the process with the next piece of cloth. After a few minutes, I can start removing any small air bubbles. The roller is very effective pressing the cloth in place. Here in the very front I need to add more pressure. A quick example of how I work with the next part. Wetting the wood surface, adding the thick cloth, and wetting out the cloth as I also shape it. I think the pencil works best for this step. The roller is good to press out small air bubbles and to press the cloth against the wood surface. It's a bit tricky to lay out a large piece of cloth. I want it smooth and aligned from the beginning, but I have to make small adjustments. As long as the cloth is not fully wetted out, it's possible to move it. With the pencil I start smoothing out the cloth from the middle. I do not add any more epoxy during this step, but focus on getting the cloth even on the surface. Now I can start adding epoxy and wetting out the cloth. To increase the conformance to the molds, I press the hull with a clamp. Another tool for pressing out air bubbles is the rubber squeegee. It's also a good tool for even out the amount of epoxy and move excess epoxy out from the oversaturated areas. I do not want excess epoxy on the surface as this will add extra weight without any beneficial extra strength. This tool is also very good for pressing the cloth and the underlaying surface together. Very difficult bubbles on uneven surfaces can need special treatment. After about 90 minutes curing, the laminate is sticky. With a hot air gun I can soften the epoxy again, drive out the bubbles and make the glass conform with the surface. As long as I heat the laminate, the viscosity stays low. I just need to be careful to not overdo the heating. Temperatures above 100 degrees Celsius are not good for the epoxy. After removing the bubbles in the front, I can continue backwards. It has taken me about 2 hours to reach the back end. Precision in this step saves a lot of time later on. Laying out the cloth smooth prevents wrinkles. Wrinkles and air bubbles will need to be sanded back and re-laminated. That is why I work from the middle of the cloth on the keel and smooth out towards the edges, avoiding wrinkles, and the roller helps removing bubbles. The rubber squeegee evens out the thickness. To keep the hull true to the molds, I clamp the edge. After about 3 hours curing at 20 degrees, I mix up a batch of thickened epoxy. I smear the thickened epoxy on the laminate. This will fill out the low spots in the laminate. As the laminate is half cured, the cloth will not float to the surface. By working with sticky epoxy, I get a chemical bond between the layers. The alternative is to wait until the layer is fully cured and then sand. That would cut into the glass fiber and still not reach the bottom of the low spots between the fibers. Instead, I mix up a third batch of epoxy after another 3 hours. As epoxy is expensive, I make sure to use up all when changing to a new canister. This third layer will build thickness on top of the glass fibers. As the layers are chemical bonded, I will get a stronger laminate. Physical bonding to the sanding tracks may let go after further sanding, forcing you to redo the whole process over and over again. The only bad thing with doing all layers straight away is that it takes time. You need a whole day for this small hull. The first layer is most time consuming, about 2 hours. But these covering layers only takes 30 minutes. With the waiting time about 3 hours in between the layers, you are done in about 9 to 10 hours. In the next building episode, I will continue with the inside. It's important to keep the pace to avoid shape changes. But these can be handled as I show in the next episode. If you found this episode interesting, please leave a comment and a like. That will help the video to spread to more people.